Okay, now let's dig into the meat of this section a little more. Let's talk about the division algorithm. When you are dividing, you may remember a long time ago, like in perhaps 5th grade, you first heard about this idea of long division. And you learned at the time something called the division algorithm, although you may not have called it that. And you learned about a thing called a quotient and a thing called a remainder. So let's talk about quotient and remainder. So if you take two integers, a and d, the reason I didn't use a and b here is because d is going to be called the divisor. It's the thing we're going to divide a by, and so d for divisor. That d in particular should be a positive number here. So if you take any two a and d with d being positive, there will exist unique. Remember that exclamation point means unique. Let's put a note about that here. Unique. There exists unique q and r, which are also integers, with a specific restriction on what r can be. Again, it has to be not negative. It could be 0, but it also has to be less than d. So it's like between 0 and d, possibly equal to 0. So there's going to be a unique q and r such that a is qd plus r. Well, we need an example to actually understand what this means. Right now, that's just a bunch of letters on a page. But a little vocabulary here, the q that exists here is called the quotient of that division, and the r is the remainder. All right, so let's do some examples. Let's take 37. Let's say we want to take 37 and divide it by something. Well, 37 is like a prime number. So, I mean, if you take your calculator out and do 37 divided by any other integer, other than 37 itself or 1, you're going to get like not irrational. You're going to get a rational number, but it's going to be a fraction, right? Because 37 is prime. But this is about dividing and finding the whole number of multiples of that divisor that go into 37, and then also asking, well, what do you have? What remainder do you have? So let's talk about dividing 37 by 7. Well, what's the largest multiple of 7 that goes into 37? That's like still less than 37. You've got 7, 14, 21, 28, 35. Oh, hey, and then you go to like 42, right? So 35. 35 is the largest multiple of 7, which is still less than 37. So this is 35 plus 2, right? And that we could write that as 5 times 7 plus 2. So in this case, when we did the 37 divided by 7, we have a quotient of 5 and a remainder of 2, right? 7 goes into 37 5 times with a remainder of 2. Let's do another one. What if we take 37 divided by 6? Well, what's the largest multiple of 6 that's still less than 37? Oh, well, it's 36, of course, because it's 36 plus 1. And 36 is 6 times 6. So now we have a quotient of 6 and a remainder of 1. So that's what the division algorithm is. You can do this with any two numbers. You're going to have a quotient and a remainder. If, by the way, I guess I'll do one more example here. If you do something like 30, no, I won't do 37 again. Too much 37. Let's just do like 10. If you want to do 10 divided by 12, a larger number, you can do that, but you would just say this is 0 plus 10, whereas it's 0 times 12 plus 10. And so the quotient is 0, and the remainder is just 10. So if you try to take a number divided by something larger than it, if you're going to divide by 12, then you just have a quotient of 0, and the entire number is your remainder. So it works. It works for any two numbers, okay? So this is called the division algorithm. It's not much of an algorithm per se. We actually are going to look at some proper algorithms that we write out in pseudocode later for computing things like this, like remainders, for example. So it's really not much of an algorithm. It's more of just a theorem, but it is called an algorithm for some reason. I don't know why. So we're going to make a definition that's going to be important in this chapter that's based on this idea of quotient and remainder. So that is that the quotient is going to be, and let me actually write out the word quotient actually. The quotient is going to be called a div the number d. So a divided by d. And div, and I'm putting an underline because in the textbook they use bold, and I can't really write in bold with my pen, so the underline is basically take that to mean bold here. A div d is the quotient of that division. And then the remainder, that is going to be a mod d. Okay, a mod d is the remainder of that division. So for example, using the example above, 37 div 7, so 37 divided by 7 is going to be 5. That's the whole number that you get. You can think of this as if you actually do 37 divided by 7, like if you actually could perform that division like with a calculator and then just truncate the decimal and like just cut the decimal off and look at the whole number part, like say divide and then round down, that would be 5, okay? So that's the same idea here. And then 37 mod 7, well, that's the remainder you get when you divide by 7. So 37 mod 7 is 2, right? Remember, we had a remainder of 2. 37 div 6 is 6, and 37 mod 6 is 1. 10 div 12 is 0, but 10 mod 12 is just 10 itself. Okay, so there's div and mod, right? This is basically, div is what you get when you divide, it's a whole number you get when you divide, and mod is what the remainder. In programming, there are actually often symbols that do these specific things, and it kind of depends on what programming language you're talking about. So in C++, for example, this C++ is what I'm most familiar with. When you put the slash, that slash performs division, and I might be slightly misremembering this. I know there's also a double slash, and I should have looked that up right before I recorded the video, sorry. So correct me, please, if I'm wrong here. 37 divided by 7, when you divide, because C++ is like a strictly typed language, which means that the type of object that you're dealing with is very strictly controlled. 37 and 7, if you have introduced those numbers as integers, the int type, then when you do division, it's gonna keep the output as an int as well. It's not going to like retype. It's not going to adjust the type for the situation here. So so C++ would always give you 37 div 7. It would give you 5. That would produce an output of 5 here. The function would return 5. Whereas if you want to do mod, the syntax that you'll see a lot is the percent sign. So 37% 5, that means mod 5. That will return a value of 2. I'm sorry, I was saying 5 and I was writing 7. 37 mod 7 is written with a percent. And so different programming languages will use different syntax for those things, but most of them have some sort of an operation that basically does div and basically does mod. And these are useful for, like, for example, if you want to check to see if something is a multiple of 7, you could do %7 and check to see if that equals 0. Because any multiple of 7 will be, that mod 7 will be 0. If you want to check to see if something's even, you can just do %2 and then check to see if that is equal to 0. That would be even. If it was equal to 1, then it's odd. So, okay, this video is long enough. Let's move on.